Farmer Laura has a big dream to expand croplands around the world. But she knows the climate is changing, and that worries her.
In the future, croplands could face serious challenges from climate change. What will decide how vulnerable they are?
Policymaker Jake is creating environmental policies. He's thinking about how to protect future terrestrial ecosystems.
Could terrestrial ecosystems experience negative impacts, such as sudden decreases? What kind of policy could prevent that?
For Farmer Laura and policymaker Jake, this paper could be helpful.
So here is an easy explanation of what this paper is about. First question this paper asks, if land use change keeps increasing, how will land ecosystem react? Looking at the future leaf area index (LAI), we see that about 5% of the planets could suffer an abrupt decrease in LAI. So, why does LAI decrease like that? Our top suspect is cropland expansion. That is because abrupt decreases were mainly found in regions with significant cropland expansion. In fact, LAI loss and cropland gain are inversely correlated. So, where are these hotspots? We found that the biggest vegetation decline during years with the most cropland expansion occurred in Western South America, Western Africa, and Eastern North America. But here is the twist. The effect of cropland expansion on vegetation wasn't the same everywhere. In other words, even with similar cropland growth, some regions are more severely affected than others. We thought climate could be one of the reasons behind that. In general, cropland expansion reduce vegetation, which lower evapotranspiration and leads to local warming. But interestingly, this climate response doesn't scale directly with the amount of cropland expansion. However, we found a strong correlation between vegetation loss and temperature increase in only these two regions. So we believe that vegetation and climate feedback mainly occur in regions sensitive to cropland expansion. To check this, we looked at the climate sensitivity of vegetation. Only those two regions have a negative LAI and temperature sensitivity. That is a key clue because negative sensitivity means LAI decrease, temperature rise, and that warming then cause further LAI decline. In other words, it creates a positive feedback. But with positive sensitivity, this feedback doesn't happen. So, climate sensitivity makes those two regions more vulnerable to cropland expansion. Lastly, the local climate conditions also play an important role, because we found that in areas were already dry or where precipitation has been declining, LAI are sensitive to cropland expansion. Therefore, Western South America, which show a drying trend, turn out to be the most vulnerable region. In short, cropland expansion can trigger abrupt vegetation loss in the future, but the extent depends heavily on climates. In particular, regions with a negative relationship between LAI and temperature, prolonged dry condition, or a shift toward drier climates tend to be more vulnerable. As a result, regions like Western South America could be especially at risk, and deforestation in such climate sensitivity area should be carefully limited in the future.